Hello everyone, once again welcome to another video on aborted engine starts. So we're just going to discuss a couple of reasons and how to action the QRH appropriately when we have to abort an engine start. What it means is that when you do your normal starting of the engines in everyday operations, you definitely pick up some values and figures in your mind and some limitations that you have to adhere to. The moment you realize that any figure is going out of its limits or is looking abnormal, you abort the start immediately, simply to save the engine so that it doesn't get permanently damaged, whereas it might have been able to be fixed, but because of you have not timed the action correctly, you may have damaged the engine. So let's visit a couple of reasons that warrant an aborted engine start. And the reasons we have here, the first one we'll talk about is a no condition lever signal. So when you put the selector switch, the toggle switch on the overhead panel, engine panel, to let's say engine number 2, and you press the start switch, immediately you have to see NH. The moment you see NH at the first indication, you bring the condition lever to start and feather. At that moment, if there is no fuel flow, it means that the computers have not processed the signal from the condition lever to the fuel delivery system in the aircraft, the FMU, to supply sufficient amount of fuel to show that the start is normal. So there is no signal between the condition lever and its associated computers, which interface with the engine to show that there is fuel flow. So that's basically one reason of aborting an engine start. Another reason is a wet start. A wet start basically happens when the ignition is off. One of the knobs you see on the overhead panel is in the off position rather than the norm position, or the igniter has failed, or the circuit breaker of the igniter has a fault. Those can be the reasons of a wet start. So for wet start, what happens is that each igniter is given 8-second time. If one igniter fails, the other igniter is automatically kicked in by the FADEC, and the FADEC starts logging in a fault towards the fault igniter. That's what your AOM will say about engine starting. So normally what's going to happen is that a lot of fuel is going to go into the combustion chamber, but there will be no ignition of the fuel. It's just going to be filling up, and that's not something that you want. So you will have no fuel flow and you will have to abort the start. The third one is a hot start, and a hot start basically happens when the ITT, the inter-turbine temperature, is increasing very rapidly, and the causes of a hot start could be that there is a trapped fuel in the combustion chamber. There will be tailwind, which can cause the combusted fuel to move to the front of the engine. That's going to give you a hot start as well. So the limitation of a hot start is 920 degrees in the Q400. So what happens at the moment you see the ITT needle going beyond 500 and above, that's enough to reason that I have to abort this start. In the simulator normally it goes to 600 mostly, but in normal operations the ITT peaks at around 420 something degrees centigrade, somewhere around there for a healthy engine. The moment it goes to 500 and beyond, that doesn't look right, and you abort the start immediately. So it will prevent you to damage the engine severely, so it's beyond repair. It's very important to time a hot start. If you think it's a hot start, don't let the limit reach and the whole ED display becomes red on that particular engine's ITT, and then you abort. You have already damaged the engine there, and it costs the company millions of dollars, which I don't think you want to be in that situation. Okay, the second one is a hung start. So a hung start basically happens when the NH compressor, the high pressure compressor, is not rotating sufficiently. It's hanging somewhere. The reasons could be like high altitude, a weak starter, and there is not enough rotation. Those are the possible reasons. High altitude airfields where there isn't enough air dense air rather. The starter is also weak, is not able to rotate the compressor sufficiently, so there is not enough rotation, and that's going to hang the compressor at a particular value, very slowly increasing, and then the moment you see that, you abort the start, so to prevent further damage of the gearing mechanisms. No oil pressure basically happens when you don't have any oil pressure being pumped into the gearing systems of the engine when it's starting for lubrication. So this can possibly be due to a failed oil pump that is not functioning well, so it's not delivering enough oil for lubrication of the gearing mechanisms. No starter cutout, basically what you expect is the starter to cut out to when the NH reaches around 50%, and when the NH reaches 50%, the toggle switch on the overhead panel returns to neutral at around 50% NH. But if the start light has remained on and the starter select switch hasn't still come to neutral, it means you don't have a starter cutout. This is a QRH item. It's not something to abort an engine start for. That's why it's in green. The other is starter failure on ground. Again, starter failure, basically the starter has failed due to some failures within it, and the starter light remains illuminated on the select switch on the overhead panel. This is also a QRH item. Again, it's in green as well. It doesn't warrant an aborting to abort the engine start, although it's in the list there, but it's not to do with anything that you cut the fuel immediately by bringing the condition lever to fuel off and the select switch to neutral, as the memory items dictate in the QRH. So although it's in this list here, or these two, the ones in green, but they don't warrant an aborted engine start, is a QRH item. Abnormal starts, basically in your daily operations, when you see the readings, they stick to your mind on healthy engine starts and how they should look like. If any reading is going beyond what you should expect, that means it's not consistent with the standard, so you abort the start. And tailpipe fire, basically what happens is that only the ground crew can say you have tailpipe fire. Mainly you might have a lot of fuel in the combustion chamber towards the rear, and the fuel ignites and there is a fire. So the ground crew will tell you have a tailpipe fire, but there is no indication in the flight deck. So you abort the start immediately to further combust that fuel that is already in the combustion chamber. Okay, so 9 reasons there that I've come across in my trainings and in my daily operations that warrant an abort engine start. Now, items 6 and 7, as I told you, require a checklist. The rest require memory items. So each time you have a abort engine start situation, there is the memory item. This is the QRH, which says condition lever to fuel off and the start select to off. Those are memory items. So immediately you action that as soon as you realize that this situation does not dictate me continuing to start this engine. Very important. And then once you have aborted the engine start, what next? What do you do? So company procedures will differ. So this is from the company I work in, but every company has got its own procedures as in what to do when you have executed the memory items for the aborted engine start and what's next. So basically, first of all, we have to understand the limitations. So first of all, let's talk of the limitation of the starter from the AOM. What does this mean? Maximum time on 70, 70, 70 to 230. I want you to understand this very carefully. You have maximum 3 start attempts. When I say 3 start attempts, I mean you have 3 attempts to push with your index finger on the start light, the square switch light next to the toggle switch on the overhead panel. You have 3 attempts to push it. So let's say, for example, your first one is a normal start. You don't know what has gone wrong. The engine is, nobody has told you anything. You jump to the aircraft and you want to start let's say the engine number 2, the right-hand engine. So you will request clearance, and then your first start attempt you will do the selection with the toggle switch, let's say to engine number 2, and then you will press the start select switch light. That is your first attempt. The moment you press that one, the first officer will time 70 seconds. This 70 seconds is for the NH. The NH should reach 50% within 70 seconds. That's your first attempt done. Now, let's say you have met an aborted engine start situation. For instance, let's say the ITT is shooting towards 920. You are going to abort the start. Once you abort the start, you will time for 2 minutes for cooling purposes, to cool down. All right, so that's going to be your first procedure done with a normal start and aborted start. Now let's say you want to motorize the engine. Motorizing meaning, we'll come to it in a moment in the following presentations, is that you want to dry motorize the engine. So you remove the fuel that is trapped into the combustion chamber. Remember, you only motorize an engine when you have fuel flow into the engine. You don't motorize an engine which has no fuel flow. For instance, for hot starts and for, let's say, no oil pressure and no fuel flow, those don't dictate motorizing, dry motoring an engine. Okay, so let's say you motorize the engine. Now remember, that will be your second push. Okay, the second push there. So the moment you have press, each time you press the switch light, the start switch light, you have to time for 70 seconds. But for motorizing, you don't do 70 seconds. Depending on the situation or condition rather, you either do 45 seconds or 25 to 30 seconds, depending on what the condition was for the aborted engine start. Okay, and after that, you again have to wait for how many minutes? 2 minutes. Okay, when you reach a stage whereby you have to do the third attempt, you need to contact your ground personnel or the engineer that this will be our third attempt. And if after the third attempt we fail or the engine does not respond correctly, and again we have to abort the start, we may have to wait for 30 minutes. Okay, it's very important that you explain this to the engineer that okay, he's allowed you to motorize after the first aborted start, but if anything goes wrong again, you'll have to wait for 30 minutes. So it's better they check whether servicing is needed, or they can tell to go ahead maybe. So that depends also on the engineer and the ground personnel. I hope that makes sense on what these times mean and these start attempts mean. 70 seconds is for the NH to reach 50% within 70 seconds. You don't have to wait for 70 seconds. Normally it reaches way earlier than that, but that's a maximum. And the 2 minutes and 30 minutes are cooling times. So you let the starter cool down before you can engage it again. Okay, so those are the limitations. Now we talk of what does it mean, and exactly I'll just once again reiterate what I've said here. So initially you have a starter generator assembly, which is a starter mode. Okay, within 70 seconds, as timed by the first officer, when the captain presses the start switch light, the NH must reach 50%. After this, the starter cuts out. The select toggle switch returns to the center, as you will be aware of. If this does not happen and the NH is slow to reach 50% within 70 seconds, we call it a hung start, which is what I explained. And now the starter can be on for a maximum of 70 seconds to prevent damage. Very important on this one. Okay, so when the captain presses the start switch light, the F4 will start at his timer. By 70 seconds, the NH must reach 50%. When the captain moves the condition lever at the first indication of NH to start and feather, he starts his timer. You see, the first officer started his timer when the captain pushed the start select switch inwards rather. Okay, and the captain will start his timer when he moves the condition lever to start and feather. Okay, and what he's observing, typical values for time are the following. Within 3 to 5 seconds you must have fuel flow. Okay, by 8 to 10 seconds you must have light up, and light up is defined as an increase in ITT by 20 degrees as per the AOM. And within 16-20 seconds oil pressure must show, and 20-22 seconds starter must be cut. These are just ballpark figures, okay? It will depend on who is observing in what way, but on average, these times are typical of a healthy start. Within these times, you need to be able to see these things happening. All right, very important to keep them in mind. However, you may have your own procedures as well. And around 35 to 38 seconds, select light will be off. Now, if you see this, by 20 seconds, the starter must be cut. And if you read the AOM on the section, engine start section, it says that the start and select lights remain until 15 seconds, okay, before they switch off. So if you add 15 to 20, you get 35. This is just plus or minus 3, plus or minus 2, maybe plus or minus 3 or 4, plus or minus 2, plus or minus 2 as well. So we just give it some sort of gap before we say, okay, now it doesn't look right, and we've got to actually shut it down. So these time are very handy, these time figures are very handy to observe all these events taking place when you start the engine. Okay, so far I'm hoping we are together. And the 8-second timing is for light up, is for one of the igniters. If in 8 seconds an igniter does not combust the fuel, the other igniter will kick in. That's another 8 seconds. So in total it's 16 seconds to decide if both igniters have failed to ignite the fuel. In normal circumstances, the FADEC is programmed to abort the start when such a scenario happens, but if you are quick to do so, you can. So the captain, upon noticing this no rise in ITT, will abort it. This is for the companies like mine where the captain does the starting. I'm not aware of any other company where the first officer does the starting. That's why I'm mentioning the procedure that we follow. But as I said, every company has its own protocols. So that's very important. So how is a table on cranking limits applied? As I've just mentioned, now I'm just going in detail. Before I was just giving you a summary. So basically what is happening here, in the previous slide only the memory items of aborted engine start was shown, as you saw. The rest of the checklist is as below. So if you look at the QRH, if you have it next to you, after the memory items have been completed, you have this part of the QRH which asks you if you have to clear an engine. So clearing an engine, as I said, you only clear for wet starts, hung starts, okay, ITT if it has not reached 920, okay, and there is, whenever you have fuel flow, you definitely have to clear an engine. But you don't clear an engine, you don't motorize an engine when there is no oil pressure. You don't motorize an engine when you have ITT accidents, okay, simply because you cannot dry motor an engine which has no lubrication. You will further damage the engine, and it will just be a costly thing on your part. Okay, so basically what happens here is that if you say this, you had fuel flow but you had to abort the engine start, the first action will be condition lever fuel off, power lever confirm is at disk, ignition, one of the knobs should be for the affected engine should be off, and then start select affected engine. You have to select, but before you do that, remember, the moment you abort the engine start, condition lever fuel off, start select off, time. Okay, so you can only execute this stage after 2 minutes. Okay, after 2 minutes. That's why it says you observe starter cranking limits. Okay, once you have motorized the engine for 35-45 seconds thereabouts, then you can go ahead and start dry motorizing it. The moment you have cooled down the engine, okay, for 2 minutes, then you can start the engine again by dry motorizing it, and then you can execute these steps. Okay, once you have dry motorized it, again you have to wait for 2 minutes. Remember, 2 motorized 2. It will come in the following presentation. 2 motorized 2. 2 minutes for cooling, then it will be motorizing for a couple of seconds, 35 to 40 seconds depending on the situation, and then after you have deselected the start switch light, after motorizing, you have a time again for 2 minutes before you decide if you have a subsequent engine start. Very important that you follow these procedures. It says here, observe starter cranking limits, and it's very important. So basically what you do here, Now let's see the sequence of aborted engine start. Is what I was talking about. Now I'm going to give you as a write-up. So first of all, you do the memory items. There they are. Condition lever fuel off, start select off. Then start timing for 2 minutes immediately. This is the time the starter can be off before you press the start switch light again. It's called the cooling time. And then advise ground personnel that you've aborted the start and you wait for 2 minutes. And thereafter, you will, after 2 minutes is up, you do the following stage of the checklist. However, we do not clear an engine for every abort. Very important. So you do only this part here, okay, after 2 minutes. All right. And then, so what are the reasons for clearing an engine? Let's talk about them. To clear an engine means you need to remove the excess fuel that was introduced in it but was not combusted. So wet start is one of them. Hung start, there was fuel. ITT, reaching the limit but not exceeding it. But not exceeding it is very important. Okay, you can clear the engine for that. And abnormal start readings, you can also do that. If it's oil pressure issues, I would recommend you don't do any clearing. Okay, and tailpipe fire, again, you can even clear the engine because you've got fuel in the engine system. Right, so the next one now, what are the reasons for not clearing an engine? No condition lever signals means you don't have any fuel, so we won't clear the engine for that. Hot start limit exceeded, you can't clear the engine for that because the engine is damaged. And no oil pressure, you can't clear the engine for that because you won't have any lubrication for the gearing mechanisms. You may damage the engine even further if you start cranking it when it's all dry. A lot of friction, a lot of heat, and bending and twisting will occur, and all the gearing mechanisms will be damaged. Okay, so you don't clear the engine for these 3 reasons. Okay, then once you decide that the engine needs clearing, advise ground, you will need to clear the engine. The term used is motorize, meaning you want to run the motor, cranking it, without introducing any fuel. It's called dry motorizing. Okay, so now here is when the captain will press the start switch light for a second time. You remember the first one was the normal one. Then you aborted. Now you're going to press it again for motorizing. So there's already 2 presses have been done. Okay, if you look at your table. And then what happens now? Motorizing times on average are 40 seconds for hot start, where IT is not exceeding 24 30 seconds for all others. It will depend on the company anyway, in your training. And thereafter, motorizing period is complete. The start select switch is returned to neutral manually, and the timer started again for another 2 minutes. You remember, you cool down 2 minutes, then you're motorizing a couple of seconds, and then once you have deselected the switch after motorizing, you'll again start 2 minutes. Each time the 2 minutes is ensuring the cooling of the starter. Alright, so after desired engine duration is complete, there we go. After the 2 minutes, start select off. And so the best way to remember this is 2M2, M being motorized. 2 minutes, motorizing time, 2 minutes. Okay, important. Now remember, the motorizing was your second attempt on the cranking. First was a normal one. I keep repeating this because people do get confused on this, and I've got confused a couple of times as well in training, though, until I was actually told what to do. So basically, what's going to happen now is that we go to the next presentation here, and on the checklist where it says if a subsequent engine start is to be attempted, you do the following procedures. Okay, you need to advise maintenance that this will be your 3rd attempt. All right, you remember, you pressed the first one in a normal way, you motorized your second one, that's the second one. Now if you have to do it again, it will be your 3rd one, and here you can't wait for 2 minutes, it will be 30 minutes if you see your table. All right, so if a failure occurs now, then it's a 30-minute wait, and maintenance action will be needed. Now it's up to maintenance to give you a go ahead or not. Very important. Okay, and then that's about it for engine starts. I think there isn't much about engine starts, rather. There isn't much that is there. And what's going to happen now is that, as I said, that there will be QRH videos coming on the platform, which I want you to see when you have the engine section. There will be aborted engine starts as well to discuss about, but it won't be a lot because there will be definitely this video which has already been given to you. So I hope everything has been understood. Unless anything, till the next time, take care, happy landings, and please do continue reading and understanding your aircraft well. Thank you.
Fuel flow. Line up. No pressure. Start at once.
Ground cockpit, 051, 5, 7.